Hello, everyone. Welcome to this episode of the Cloud Native Testing Podcast. I'm super happy and thrilled to be joined by Sachin from Cloudflare. Sachin, how are you?
I am great. I'm hanging out in San Francisco in my balcony, so I'm pretty excited to be here. Thank you for inviting me and talking about cool testing stuff.
Well, thank you for joining. So just before we dive in, tell us a little bit about yourself and what you're doing at Cloudflare and anything else you want to add about testing,
Yeah,
maybe in
so
specific, but go for it.
absolutely. A few years ago, Cloudflare sort of realized that were pretty critical infrastructure for the internet, and we could no longer sort of YOLO things into the ether and just expect them to sort of work. And incidents became really sort of a critical focus for how we wanted to become resilient and making sure we keep things running for our customers. And so we ended up coming up with this idea of a testing at scale team, and we didn't
Hmm.
really back then know what that meant. I love breaking things, I love testing things, so I sort of put my hand up to volunteer to be the one of the first people on that team and sort of help spin that up. And so that's what I do. I help. Today we have a few folks on our testing at scale team, and we provide critical infrastructure to a lot of our internal teams at Cloudflare, and it's been quite cool to see that growth where we didn't have a testing at scale team and now we do. So I help sort of manage and grow that part of Cloudflare.
Okay, awesome. Thank you. I mean, I'm sure people listening and myself, obviously, when just as you said, when I hear Cloudflare, I think scale. So I'm curious, kind of how can you test at the scale that you guys must be having, and how do you break that down into tests that kind of give a realistic measurement of what your capacity is? We don't have to go into numbers. I'm just curious about what's the process for that.
Yeah, so we have this internal thought process at Cloudflare where we really leverage Cloudflare's superpower is really like its network is one of its things. We have interconnectivity across the globe and all of these co-location sites and things like that. So it's fairly interesting for engineers because they write software and they'll deploy something and suddenly it'll become the most available, most resilient something that they've ever deployed, right? And that sort of works on every level. And so for the testing at scale piece, we had a similar thing happen where we were like, well, we have all of this overpowered infrastructure at the edge. We should figure out how to leverage it to run a lot of our testing infrastructure and things like that. So at this point today, we started out pretty small. Actually, my engineer just wrote a blog post on some of the things we did to unlock new capacity and how we were
Hmm.
planning on scaling, because the internal teams themselves started pushing us on scale because they were like, hey, my default traffic that I'm doing is like this much and your testing traffic isn't like keeping up with that.
Hmm.
I want to add more tests, but your infrastructure isn't supporting it. Like, how do I add more tests, add more probes, or add more, blanket my service with a bunch of like
Hmm.
good requests or bad requests or
Hmm.
whatever.
Hmm.
And so he just wrote a recent blog post that went from a daily test unit of hundreds of thousands to tens of millions of tests per day. And
Wow.
so we were able to like do that jump in 6 months, and we did that jump with more headroom than we had before. And so to answer your question in sort of like a roundabout vague way for now is we really leverage Cloudflare's existing network and infrastructure. I can tell you a little bit about the tool that my team
Hmm.
provides. So it's a thing called Flamingo. Like, the service that we run is called Flamingo, and it's a service that runs on every Cloudflare edge metal. So everywhere that we have a presence, there will be a Flamingo, and Flamingo. Only internal Cloudflare or my team currently and my team services can talk to these Flamingos, sort of issue requests to run a test to these edge Flamingos, and we say, can you run a test that does this type of request for this team or this type of traffic for this team, and the Flamingo will kind of realize where it's running and say, I can do that, let me do that. And so it'll look at that request, service it, and then emit metrics around it pass, did I blow
Mm-hmm.
up? Did it fail? How did the network react to that and things like that? And then it'll phone home with those results. And so that's basically how we ended up leveraging our current infrastructure
Mm-hmm.
to be able to run these tests at scale.
Mm-hmm.
Now, one of the challenges that actually shows up, which was quite interesting, is we have a singular control plane in our core infrastructure that gets phoned home. And when you realize how much more powerful Cloudflare's edge infrastructure is than your tiny little
Mm-hmm.
service requests, like responding to all those requests, basically you have a self DDoS kind of situation, right? Where you issue a bunch of tests and then suddenly like millions of these flamingos are trying to phone
Mm-hmm.
home and say, I ran that test, like I did a thing. And so we noticed that our control plane became the singular point of failure and started like really struggling to keep up. And so those were some of the improvements we made that my engineer sort of blogged about to improve that scale a little bit on our end. So it was quite fascinating to sort of see uh, we could do the flamingo part, the edge
Mm-hmm.
part, pretty easily because of the infrastructure that
Mm-hmm.
existed. Uh, and then we had to really think hard about how we handle that capacity that
Mm-hmm.
Cloudflare provides on our end. So it was quite
It's
yeah, it was quite
super.
fun. It was quite cool.
It's super fascinating. It seems to me like there's a meta level here. There's running the tests is a test in itself, or running the test at the scale that you're running them becomes a test on the system itself. Is it able, is your control plane with all those flamingos able to run these many tests at the same time and aggregate all those results, which becomes like a self-testing system? That sounds super fascinating, and it must be, to your point, really interesting to see just because of the scale that you have that your infrastructure operates at.
Yeah, we also adhere to pretty strict SLOs and SLIs for ourselves
Hmm.
because we consider ourselves critical observability tools. So whenever there's something that's horrendously broken or something is kind of not working the way teams expect, they're under a lot of load and stress, right? And like it's one of those times where they really rely on their tools. And specifically for us, it is more important to work when other team services are not working. So we take our SLOs and SLIs very seriously around what are our dependencies. So we also try to push our dependencies to declare their own SLOs and SLIs because you're only as available as your Postgres database or your Prometheus scrapers and like whatever else that you like rely on implicitly without realizing just gets baked into your SLO and SLI because the moment that breaks, it doesn't work. So we're trying to work on degraded availability and things like that too, to sort of say, well, if these core systems at Cloudflare are sort of blown up, how can we still provide value to the teams to say, well, did it pass or not? That's actually all I care about right now. Everything else we can get back to later. But being able to provide certain critical data in those situations has been really helpful. And we measure some interesting things. So a lot of we've put a lot of thought into our SLOs and SLIs. So like the
Hmm.
simple ones are sort of like you have your uptime and your availability, and you say I calculated my over my total requests, and that's how much available I am. So those are some basic ones that you kind of want to do and things like that. Maybe you have your API latency and all of those things. But we actually found that the most interesting lows and SLIs for us are around data.
Hmm.
And so one of the interesting ones that we have is we have a heartbeat job
Hmm.
that we run for ourselves. And this is one of the meta tests that we run at vast scales. And all we do is like a hello world across the flamingos to say, hello world, like we issued a test and it came back and it's a hello, and we monitor that for data loss. And so we say every how many seconds or how many ever minutes this should have this many data points. And
Hmm.
if that's missing. And so let's say we expect it to run every second, right? You should have at least 60 test runs. Maybe they passed, maybe they failed, whatever, but you should have 60 data points. And so if you have 55, you're losing data. And so that's sort of how we measure our data SLOs and things like that. And that's been really interesting because it reveals certain nuances and weird data things where some of your minutes have one extra data point and you're like, what's happening here? Like this, we're
Where did
miscalculating
that come
certain
from?
things.
Yeah.
And so you can calculate drift. And then the other availability SLO and SLI that we sort of have is teams can schedule things on a ticker, and that allows them to sort of blanket their service with certain tests at all times of the day. And so, some teams run it every minute, every how many ever. Some teams run it every hour. Some teams have very big tests that they're like, well, actually, I don't do that many deployments. I just want to run it every day and make sure that, like, at this point every day, it's fine. So one of the SLOs and SLIs that we put in there was every test has a start latency or a test latency of less than 5 seconds. So for whatever reason, if you've scheduled your plan to start at 6 p.m. and it starts at 6 p.m. and 10 seconds, that is counted towards a failure in us to meet our SLO. And so that number we actually closed in on, and we said, well, right now I think we do it almost exactly on time. Everything happens exactly on time. But it reveals interesting things because the more you scale, a lot of this is based on like queuing and capacity. And so the more you scale and the more stuff you have in the queue over time, just the ability to service things on time falls away. Because 1 second is like a lot of time. But when you do it at scale, it's not a lot of time to hit everything, especially when time is really critical and you really want to get those timing things correct. So yeah, that's been
How did
really
you
fun
solve that though?
to
Is
think
it
about.
by introducing, like, I don't know, some infrastructure components, or I'm curious to learn, obviously, what.
Well, so one of the answers is like you throw more hardware at it, right? Like
Okay.
that's one of the easy answers. So we did a little bit of that. We added more like CPU capacity, added more mem, um, more deployments, more pods, whatever, because you do need some of that because Cloudflare's edge is extremely overpowered. You're not going to be able to keep up with that with just a limited amount of hardware capacity. You need some amount of hardware to actually deal with the vast amount of hardware on the other side, right? So there is that component. But one of the things that we were doing there is we had this just singular worker queue that was picking up jobs and like doing these jobs on the schedule and working through the queue, and it was actually working fine. Like it didn't show up as any problem, and no one was complaining until we started measuring stuff. And this is when we started measuring the data pieces and the plan latency pieces. Actually started backwards, where we were like, well, from a human perspective, it feels like everything's on time, like everything works and no one's complaining. But the moment you get accurate with metrics, so it's the same engineer that wrote the blog post. His name's Wyatt, but he started this approach of data-driven development. And so he is obsessed with graphs and metrics.
Okay.
So before he starts a project, he just spins up a bunch of graphs about everything. And so he will measure, like some of his first tickets are just add metrics for this, add metrics for this, add metrics for this. And so he will lay out all of the metrics, all of the things that he wants to measure. And it's funny, like some of his graphs will start at 0%. And he said, I want to make this 100%. And he'll work on, then it becomes like this very concrete thing. And so if he makes a change and it makes no difference to the 0%, like he's like, okay, I'm not, this doesn't count. But the moment it pushes it to like 5%, 10%, and so like that's how he progresses doing his data-driven approach. And so some of the things that we were measuring, we realized the spaces that were sort of choking because of those metrics were things like Go routines. We were like using too many Go routines per CPU capacity and things like that. And so that was like affecting throughput over time.
Mm,
He came up with this cool way to schedule and hash each test to run based on the hashes per
mm,
job worker and things like that. So we did a lot of like intelligent queuing, sort of building out a queuing system and things like that. But the key unlock there was measuring the stuff first and then going from the data of what are we trying to improve and writing that out in words to say, well, we want plans to start on time. And then what does on time mean? Well, we're okay with 5 seconds. And so the moment we measured that, it was at 0%,
mm,
because it would be like, yeah, it would be at 6 seconds or seven
mm.
seconds. And we're like, it seems fine as a human, but the
But
directionality is wrong, right?
yeah.
So yeah.
So, but are you then continuously monitoring all your tests and everything to kind of detect if things slow down or you're introducing latency in one of the sub-tests that you're doing? And if you are, how have you automated all of that? And it feels like there could be a lot going on at the same time. And how do you make sure that you're really catching those anomalies that are important versus,
This is
noise, I guess?
this is a great question, and it's one of those things that doesn't just apply to testing at scale, but most teams have this where humans are just bad at time. Humans are good at availability. Like you can tell when a thing is working or not working is very easy to complain about. You make an API request, it doesn't work, and you're like, fine, it's broken. Pick that up pretty easily. Uh, when was the last time you like opened Google and you were like, oh, this is slightly slower than my last Google query? Like, never, right? Like you're never thinking about. You're just okay waiting for the spinner to go up, or like humans
Yeah,
are.
or
I've
you
I've
just
come
blame it on
to. Yeah,
yourself, right? It's my network. It's not
it's my
Google.
network, right? Right, exactly. And so when we and that the problem is compounded when you have asynchronous things running at such large scales beyond your purview. So you're not actively like teams are scheduling this stuff, and they're scheduling it at such vast scales that it's almost impossible for us to know per test, like, did this actually run at like this millisecond of this time when we had
Mm,
scheduled this across the board over millions of tests. And it's like, yeah, it's kind of hard to measure. So we have an SLO team at Cloudflare, and we worked very closely with them to sort of understand how to tie these pieces together. And any time we discover something that we missed during an incident, we
mm,
immediately convert that to an SLO. And so we say, so if something sort of broke and it didn't show up on a graph, that's an SLO, because it means it's a space that we sort of haven't been able to observe and look into on a graph, and convert that into some sort of solid number that you can
mm,
start monitoring. So the moment you have that graph, you can then understand the gradient of that graph,
mm,
right?
mm,
And so if it's flat, you're great. If it's going down, something's wrong. And so then the next step is the moment you have the gradient, based on the angle, you can choose to alert or not alert on that graph. So maybe, across millions of tests, if we schedule one test 1 second off of the time that it was supposed to schedule at, is that a problem? I don't know. I don't want to get paid for that, right? Like that.
mm.
Fine, we did it correctly at the next second. But if we scheduled 500,000 tests wrong out of a million tests, like that seems like a pretty big
Mm, mm,
misstep there, right? And that is something I do want to get paged on. And so we have the SLO team came up with the idea of burn rates. And so burn rates are basically the calculation of that gradient
mhm,
and understanding how much of your error budget are you burning per time that you've specified. And so if it's slowly decreasing and you have maybe a week till it hits your 99.98 instead of
Mm-hmm.
99.99, maybe you send a chat notification and say, hey, you're burning
Sure.
your error budget. FYI, like, this isn't a problem yet, but it will be in a week, right?
Mm-hmm.
Um, but if you're breaking something and it's burning your error budget at like a percent per minute,
Mm-hmm.
it's going to page you
Yes.
immediately,
Yeah.
and it's going to say, "Hey, this is broken." So I'll give you a pretty interesting example of how we
Yeah.
face this all the time. So we had an issue where we had a bottleneck, and the bottleneck was just preventing our ability to add more capacity to our control plan. So we fixed that, and we were like, oh, cool, like this is great. Like the person that wanted to schedule, X number of tests per minute or whatever could now do it. And then we noticed that everything was fine. No one was complaining,
Mm-hmm.
but our response time decreased by like 50 milliseconds or something.
Mm-hmm.
It was very interesting because no person sort of noticed this, but we made things just a little bit worse.
Okay.
But we solved the person's problem, right? And we just made it a little bit worse. And we realized that we forgot to bump another number that needed to like go in a correspondence to that other thing that we bumped.
Mm-hmm.
And so now, yeah, I was using a bunch of CPU capacity, but the memory was thrashing and then preventing a bunch of other things from happening. But
Mm-hmm.
that only affected latency a little bit. And it only showed up on this graph and nowhere else.
Interesting. Yeah.
And so we actually then saw that and we were like, oh, we made things a little bit worse for everyone else, including us.
Mm-hmm.
And we unlocked this use case for this one person. We would have never discovered this if this was not plotted out or not on this graph, right? And so the only way, and then we basically bumped that, and then everything flatlined again and went back to where it was. And we were like, great,
Mm-hmm.
we did both things. We like kept
Mm-hmm.
our latency where it was supposed to be, and then also ended up being able to be more available and more everything. And so I think teams suffer from this fairly often, where we make things like a little bit worse, no one notices it, but we end up fixing the bug that we wanted to, or we end up adding that one extra
Mm-hmm.
check that does something. We add that one extra database query that did something else. And application performance monitoring and all those things
Mm-hmm.
are good, but they don't generally represent
Patch
the end
everything. Yeah.
user experience and the whole customer journey that your customer is experiencing. And especially internally and through technical customers have a high threshold for nonsense, right? Like they will generally work around all of this stuff
Yeah.
and not complain about. They have empathy for other engineers and other things, and so they
Mm-hmm.
generally don't complain. So you can't rely on them to give you that feedback, just like most other sort of standard users
Mm-hmm.
that'll say, oh, this is slow for me, it doesn't work, like your thing is broken.
Mm-hmm.
And most internal customers will not do that. So that's been an interesting way to monitor, is just graph out and metrics out everything, and then use error instead of deciding if the graph is correct or wrong. Use things like burn rate alerting or error budgeting to understand how much time we have to fix this thing and how serious this thing is. Like, should we
Mm-hmm.
page on this yet? Is this a thing that will eventually sort of resolve because of another incident happening over there and it's not something we can fix right now? So that's actually been really fun, and I've only ever done this type of development on this team because of the level of scale and being core observability for everyone else. So
No, I love.
it's been quite fun to do
It's
that.
fascinating, and I love this concept of error budgeting, where you can say, "This is our budget for errors," and this is, and then you can kind of work against that. I'm just kind of trying to think through how that could play out in, different types of tests and different types of errors. It's super interesting. It's a super interesting concept. So definitely something I'm going to spend some more time on. I wanted to ask you something that we come back to in almost all of the podcast episodes, and which is testing in production. And I'm curious, kind of the tests that you run, are these kind of pre-deployment scenario, or are they running in production, or both? And in either case, what's your stance on testing in production, and if that's something that you do at Cloudflare or do not, or if it's something you've kind of discussed?
Yeah, so it's definitely some. So my team only does testing in production,
Okay, awesome.
and the reason is sort of pretty simple, right? Like, where do your customers experience issues and the challenges like in production? And with the complexity and the scale of Cloudflare, there is it is extremely hard to reproduce your production environment in some safe space.
Mm.
You could call it staging, but are you really going to duplicate your entire production infrastructure in staging? No, like that doesn't make sense, right? Like
Mm.
you're not gonna spend the same amount of money, the same amount of capacity, the same amount of. I've tried to have this be reality for like a lot of environments, but staging always almost drifts away from production in some way, and that has value too. You can sort of calculate how your performance might behave in production. You can do things like, did the service boot up? Like, that's, yeah, sure, like run that test right in staging. Like, definitely don't want to deploy something that's completely exploded in production. So you can do those sort of basic minimal tests in staging for sure.
Mhm.
But the moment you get to extremely complicated teams, I mean, there's like dozens of teams just deploying one part of the edge stack at Cloudflare. And so how do you coordinate everyone's releases in staging to make sure like the stack of software that they're running the test on is valid
Mhm.
and is going to completely represent what's happening in production? It never will.
Mhm.
It might be close,
Mhm.
but it's not really going to do that. So the only way to completely guarantee that the thing that you're running represents a user experience is to do it in production. And
Mhm.
a lot of people are like scared of this concept of
Yeah,
like, oh
yeah,
my god, we gotta
exactly.
like test this thing in production. But you shouldn't be. Like, it's your software,
Mhm.
you're deploying this to production. I think the fear comes from the fact that we might discover something in production. And it's like, no, that's
Mhm.
a good
Sure.
thing. Like, you've discovered something in production. Don't shy away from it. Like, lean into why this is
Mhm.
being weird in production. So that's one piece. And the other piece is very obviously the scale piece. Like, we
Mhm.
can't achieve the scale piece
Mhm.
that production provides in any other environment. We would have to come up with
Mhm.
like
Sure.
another Cloudflare to do that,
Mhm.
right? And like, that's not something we can
It's
do.
not realistic. Yeah.
And in terms of how we build out, we have this concept of like sort of edge slivers and things like that. So Cloudflare will partition out how we do these deployments, and so they sort of progressively roll out to each piece of Cloudflare's infrastructure. And so some of them, even though they're production, are designated to behave differently. So a
Mhm.
large section of them will be the real internet, but only Cloudflare employees will hit that colo.
Mhm. Mhm.
And that allows us to sort of, dog food the actual internet before you hit the actual internet
Mhm.
to make sure that the stack that we spun up for the real internet is working.
I
And
see. Yeah.
so teams can go target that infrastructure, and it is production, right? It's still actually running the real internet. But it's only served to Cloudflare employees. They can go target their tests against those things. They can target their tests against any of this infrastructure, so they can choose to run and validate their tests in different infrastructure slivers. So that's one way that we give teams more control over quote unquote what staging might be. It's still
Mhm.
production, it's a real
Yeah.
world thing, but it's not something that's treated separately from production itself.
Okay.
So my team is a complete proponent of production stuff. It's like, well, depending, like the goal is to always have customers have sort of the best experience. So we don't recommend trying to break your service via load testing or other things in production. because it's not a good experience for customers. But if you want to load test in sort of like a production like environment, that's something that we can help with. But you should be running your tests. Like I said, all of the flamingos run on every sort of edge infrastructure node that we have, and so those are all production nodes. They're all
Mm,
serving
mm,
live traffic to live customers, and that is the exact stack that a customer will be hitting at that exact time. And so we know if something fails, it's failing for our customers.
mm,
Like, it is not something that we made up that is like, oh, this is failing in staging,
mm,
and so we can very confidently then alert on those SLOs and SLIs for other teams on their
mm,
behalf to say, hey, if we're seeing this failure at our scale, like, your customers are definitely seeing it. Like, this is happening
mm,
here. Like, and even in that complexity, like, like, it might fail in a particular region, in a particular transit, for some random situation that you had no idea existed. Like, maybe an ISP is doing something weird, someone else is doing something weird. We changed this one metal to do some weird behavior, and so we've been able to pull up all of these strange things in production that you really wouldn't get in
mm,
staging, because it's such a fake, contrived sort of environment that we spin up
mm,
to stage changes to production, but they
mm.
they rarely ever map one on one. So
Okay, Sasha, this is fascinating, and I'd love to continue, but unfortunately we're out of time. So thank you so much for sharing everything you've shared with us. I have so much things in my running in my head now that I need to make sure I capture afterwards, but I'll just re-listen. Super inspiring. Thank you so much, Sachin, for joining. And thank you, everyone else, for listening. Thank you, producer Katie, for producing. And have a great weekend. Bye bye.
yeah, thanks for the invite. This was awesome.